Hello there. This video is on AP Calculus BC 2024 FRQ2 solution. FRQ1, by the way, of BC is same as AB, so I already have a video on that. Let's read this one out. A particle moving along a curve in the xy plane has a position of x, y, so it's in terms of parametric coordinates at time t seconds, where x and y are measured in centimeters. It is known that x prime is this and y prime is this, and at t equal to 2 seconds, the particle is at this point. So this is the position of the particle at 2 seconds. Find the speed of the particle at 2 seconds and show the setup of your calculation. So in case of parametric coordinates, we have to remember that the speed is not only given just by the x direction, but it's given by y direction as well. And the derivative of the position is the velocity, right? So we're going to find the velocity first. We are interested in x prime 2. So x prime 2 is just going to be 8 times 2 minus 2 square, which is 16 minus 4, which is 12. And the unit is going to be centimeter per second, centimeter per second. And likewise, y prime 2 is given by negative 2 plus square root of 2 raised to 1.2 plus 20. Obviously, I'm going to use a calculator here. If I use a calculator, this comes out as 2.72201 centimeter per second. Since they are interested in speed, so speed is nothing but the magnitude of the velocity. And we know that x and y directions are at 90 degrees. So we're going to say that the speed at 2 is going to be using the Pythagoras theorem, because like I said, these two are at 90 degree. So the magnitude of the two vectors which are at 90 degree, where x is over on the right and y is over is upwards, is given by square root of the x velocity square plus y velocity square, which is this over here. So this value comes out as 12.305 centimeter per second up to 3 decimal places. That is the answer to question or part A. Right, let's move ahead to the next one. We have to find what is the total distance traveled by the particle over the time this and show the setup. So we know that the total distance is given by the integration from we need to find from 0 to 2. So from 0 to 2, that's the antiderivative of the speed dt. And what is speed, guys? Just like we found in the last question, at a particular point here, we need to find the general expression for the speed, which is going to be square root of x prime t square plus y prime t square dt. Unfortunately, we are given both of these expressions. So let me just plug that in those gross expressions. And this is going to look like 0 to 2 is square root of, by the way, there should be an absolute value over here as well, because that's what the speed means. But by default, since we are, just taking a square root of it, it doesn't really create any difference, because that's always going to be positive. But just so you know, the speed is given by the absolute value of this thing, just to avoid any confusion. So I'm gonna put x prime t square and y prime t square here, which is 8t minus t square plus negative t plus square root of t raised to 1.2 plus 20. Oh my goodness. Square, and then there's a dt for which I don't have any space, so let me make some. All right, then there we have a dt over here. So that's going to give us a total distance. Let me plug that in. So this value comes out as 15.902 centimeters. That is the answer for part B. Let's talk about part C. Here we have the y-coordinate of the position of the particle. That's what we need to find at time t equal to 0. The y-coordinate of the position at time t equal to 0. And we know that at t equal to 2, the y-coordinate is given by 6. So this is to be done using antiderivative of y prime, because if we need to get y, we need to integrate or find the antiderivative of y prime. So y prime is integrated from 0, y0, because that's where we need to find, and to 2, y2, because that's a reference point which is given to us. We know that the integration of y prime is just y, and we need to put the bounds, lower bound as 2, lower bound as 0, and the upper bound as 2. And this is where I use an FTC, y of upper bound minus y of lower bound. And this thing, for that, I'm going to use a calculator real quick. So I'm going to do integration from 0 to 2 of y prime t dt. So if I'm going to do that, I'm going to end up with an expression which looks like 7.173613. So all we have to do is plug in the value of y of 2, which is 6 over here. So 6 minus y of 0. I'm going to subtract 6 both the sides. So I'm just going to subtract 6 both the sides. It's going to look like 1.173613. That is the value of minus of y of 0, which means that the y of 0, as in the starting position, is minus of that thing, just by flipping the omelet kind of. So y0 is minus 1.174 centimeters. That is the position at t equals 0. This was part C. I hope this makes sense. Let's move to the last part, which says that between 2 and 8, the particle remains in the first quadrant. Find all the time times t in the interval 2 to 8 when the particle is moving towards the x-axis. All right, so we know that the particle remains in the first quadrant, right? Remains in the first quadrant. So first quadrant is obviously somewhere over here. This is where the particle is moving between 2 to 8. And they are asking all the times when the particle is moving towards the x-axis. So if anything has to move towards the x-axis, it has to go downwards. Is that correct? And going downwards means that the y velocity, the velocity towards the y direction, will be negative. So the velocity towards the y direction is negative, which means that velocity is given by y prime t should be negative, which means that negative t plus square root of t raised to 1.2 plus 20 should be negative, and we have to make sure that the value of t is given between 2 to 8 seconds. So all we need to do is plug this into our calculator. Between what you can do is you can just plug in, or you can graph this function, right? You can graph this function, but make sure you set up your window between 2 to 8, and just find out that when it is below the x-axis. So below the x-axis is the one where it is going to be obviously negative, and that's what we are interested in. So if I do that, I'm going to get the value of t as 5.222, and this onwards till 8. 8 can be included because 8 is also included here, and at 8 the y prime is negative. So this is the interval of time when the particle is moving towards the x-axis, or in other words, going and then y prime is negative. I hope this makes sense. If you have any questions, please post it down in the comment section, and I'll see you in the next video. Bye-bye.